Today we're going to look at a common problem in load-balanced web apps, web-server queuing. Queuing occurs when one part of the stack, typically the application server, has lower throughput than the request volume. This results in longer response times because the request has to wait in an upper level for the lower level to become ready. Let's look at how this might manifest in a Ruby on Rails application, which we have set up right here. Our Rails app is a single mongrel server behind Apache. Our first clue that there might be queuing is right here in the layer breakdown. Apache seems to be responsible for more than 50% of the request latency. Ideally, this should be less than 50 milliseconds per request. Since this seems out of the ordinary, let's drill down on that layer. Additionally, within this layer, let's look at exactly what the distribution of requests is. So let's switch to the heat map. Let's also expand this view to make sure we're seeing all the outliers as well as the trend. Apache's performance can vary depending on a number of things, such as client connection speed. A mobile user takes more time to download content than a desktop user. Though, looking at this graph, that doesn't seem to be the case. Our Apache response times are universally high, something that we wouldn't have been able to see just by looking at the average line. This is certainly looking like queuing, but let's really make sure and look at an individual request to verify what's going on. We can select individual traces here on the heat map, so let's pick one of the slowest where the effect would be the most severe. This will filter us down to just that trace, and now we're able to view just that request. Here we find the smoking gun. Not only do we see this request taking most of its time in Apache, but it's all before the app server even receives the request. The connection speed of this client seems fine. That would appear as a block of time spent in Apache after the Rails request returned. The web server is just waiting for the app server to process this request, adding an inordinate delay to what would otherwise be a quick page load. Once we've found this problem, the solution is just to add more capacity to the application server layer, either by tweaking the settings to enable more processes, or, if this was a larger environment, adding more servers. Here's what this same trace looks like without any queuing. The response time has dropped from 2 seconds to 250 milliseconds, and virtually all of the time is spent in Rails actually doing work. All of this because of an easy tweak to our application's config. If you think your web application is queuing at the web server layer, install TraceView to find out.